Okay, we're starting off with dividing radicals, and I know we're starting off with multiplying, but they are being used in order to divide. So we'll go through how to multiply radicals again, because we're going to need to use that for division. I know it sounds weird, but we will. Bear with me. Believe in me. Okay. So we need to expand this. This is from yesterday, so the multiplying. So we would FOIL. We would go first times first, so 2 times 2, which is 4. And then we do outer. 2 times root 3 is 2 root 3, yeah. And then 2 times negative root 3. What would that be? 2 times negative root 3. Negative 2 root 3. And then last times last, so negative root 3 times root 3. Whenever you multiply two radicals together that are the same number, it just gives you that number. So for example, root 3 times root 3, you would multiply what's under the radicals together, right? And what's in front? So it'd be 1 and 1, would just say 1. The root 3 would actually be root 9, which is 3. So when you multiply two radicals together that are the exact same, you would just get that number without the radical sign. So negative root 3 times negative root 3 is negative root 9, or just negative 3. And then you collect like terms. 2 root 3 and negative 2 root 3 cancel, and I'm left with 4 minus 3, which is 1. Now what I did there was I actually multiplied by the conjugate. The conjugate means the exact same two binomials, but opposite sign. Wait, it's going to break. So this one here was 2 in root 3. This one here was 2 minus root 3. So the conjugate of that would be 2 plus root 3. So we need to identify the conjugate of this one. So that's what we're... yeah. So what would we get? So yeah, it'd be root 7 minus 4. Now, let's multiply these together and see what happens. So, first times first. Root 7 times root 7 is? Yeah. Because you only switch the middle term. Yeah. It's going to be 7. And then root 7 times negative 4 is negative 4 root 7. And then the inside terms, you're going to get root 7 times positive 4, which is positive 4 root 7. I went to go say plus and positive, and I said positive. So there you go. Two together. And then last terms. So 4 times negative 4 is negative 16. What happened to the middle terms? They canceled. What happened to the middle terms in the previous one? They canceled. So when you multiply two conjugates together, what happens to the middle terms? So then we would be left with 7 minus 16, which is actually negative 9. Will it always turn out to be just a number? It should, because that's why you multiply by a conjugate. You multiply by a conjugate to get rid of the radical symbols. So to get rid of the radical symbols in a denominator, you multiply by its conjugate if it's a binomial. Rachel? Because like radical 3 times radical 3 is radical 9, which is 3. So like root 7 times root 7 is root 49, which is 7. Yeah. Shh. No, conjugates means the terms have to be exactly the same, opposite sign. I have no idea what you're talking about. But then that wouldn't be a conjugate. No. It's square root signs. Yes. It can't be a cube root is what I'm saying. They have to be square roots. So you aren't going to have 3 of them. So we can never have radicals. It was close. We can never have radicals in our denominator, so we have to get rid of them. Well, when I have 2 terms with radicals in the denominator, how do we prove that we would get rid of radicals? You guys are such great people. How do you get rid of radicals in the denominator? You multiply by... So we want to get rid of the radicals off the denominator, and we don't want to look up Russian words. We want to radicals in the denominator. So we're going to multiply by the conjugate. What is the conjugate to root 6 minus root 2? Root 6 plus root 2. Now, we can't just randomly multiply a denominator by something random. But we can multiply a denominator and a numerator by it. Now, the reason why that is technically if I multiply by 3 on the top and 3 on the bottom, I'm multiplying by 3 over 3. And what's 3 over 3? 1. And when I multiply something by 1, does it change it? No. So that doesn't matter. So as long as I do it to the bottom, I have to do it to the top. Or if I do it to the top, I have to do it to the bottom. Okay? So we're trying to get rid of the denominator here. So we're going to have to FOIL the bottom and then just distribute the top. Why am I not FOILing the top? Because the one on the left-hand side only has 1 term. So it's just distributing. FOILing is distributing. It's just an acronym to help you out for a binomial times a binomial, right? So in the top, I'm going to get 3 times root 6, which is 3 root 6. Plus, what's 3 times root 2? And then on the bottom, we're going to FOIL it. So we get root 6 times root 6, which is 6. And outside, root 6 times root 2 is root 12, so plus root 12. When I FOIL my insides, I better get minus root 12, because the middle ones need to cancel or I didn't multiply by the conjugate. So negative root 2 times root 6 is minus root 12. And then negative root 2 times root 2 is negative 2. And these 2 middle ones canceled. If the 2 middle ones didn't cancel when you multiplied by conjugates, then you did something wrong. So on the top, I have 3 root 6 plus 3 root 2. Can I reduce the 6 or the 2 at all under the radicals? No. So they're staying. Can I put them together? Yeah. No. Because they don't have like radicands. So they're staying together on the top like that. What's on the bottom? 4. Now, if you could take a number out of, which you can't, but say you could take a number out of this coefficient, and the denominator, if you could actually take something out of them, like a 2, like divide out evenly, you would. But is there anything common to 3, 3, and 4 that I can divide into each of them? No. So I'm done. You would take 2's out. So you divide by 2 or multiply by half, yeah. No, because it would be gone. If you do it to all of the terms, you're dividing the top by 2 and the bottom by 2. Those would cancel as a 1, right? Yeah. Shh. It's just out. So if you're taking it, as long as you take it out of the top and the bottom, it's gone. Because it'd be like you divide 2, divide by 2, divide by 2. So dividing by 2 on the top and the bottom would actually cancel each other out. Yeah, it's like reducing a fraction. Yeah, exactly. Okay, so what happens if the denominator has only one term? So simplify each quotient. Identify the values of the variable for which the expansion is a real number. We don't have to worry about that for now. We'll deal with that on Monday, or Friday. But if we just have one term in the denominator that has a radical, the problem with these questions is you can't have a radical in the denominator. It's not allowed. So if you have two terms with radicals in the denominator, you multiply by the conjugate to get rid of it, right? To get rid of those radicals. If you have one radical in the denominator, you just multiply by it. Because if I take root 3 and I multiply it by root 3, what am I left with? 3. Is that a radical? No, I fixed my issue. So root 3. But what did I tell you before? What you do to the bottom, you have to do to the top, where it changes the whole thing. So 2 root 51 times 3 is what? Root 153 over 3. Now we have to check, can 153 break down into any perfect squares? What? 9 and 17? So we can go 2 root 9 times 17 over 3. When the 9 comes out, it becomes a 3. And you're left with 6 root 17 over 3. Am I done? No. If out of all the coefficients I can take something out, I do. So what's common to 6 and 3? 3. So 6 divided by 3 is 2. And 3 divided by 3 is 1. And so it's going to be just 2 root 17. If it's over 1, do I have to keep the 1? No, but if it was 1 over 2 root 17, would I have to keep the 1? Yes. Okay, so if it's just one radical, you multiply by the radical. Now, I'm going to give you another example in between. I'm going to call this A.1. So 3 root 5 over 2 root 3. So if it's a binomial, you multiply by the conjugate. If it's a monomial, you multiply by the radical. Now, would I need to multiply by 2 root 3 to get rid of the radical? You could, but if I multiply by just the root 3, it gets rid of it, doesn't it? So do I need to, if I multiply by 2 root 3, I'm going to have to reduce it more. That's all that's going to happen. So you still only multiply by just the radical if it's a monomial. If the bottom is a monomial and doesn't have more than one term. So if the bottom has a radical in it, but not 2 terms, you multiply by just the radical. If it has 2 terms, you multiply by the conjugate. So on the top, we're going to get 3 root 5 times 3, which is 3 root 15. And then on the bottom, we're going to get 2 root 3 times root 3. So if you don't want to skip the step, you could go 2 root 9. So we get 3 root 15 over 2. And what's root 9? 3. Could I have just went to 2 times 3 and not done the root 9 part? Absolutely. But some people then try and add them, or they don't know what to do with the numbers. So if you don't want to skip that step in the middle, don't. And so then we have 3 root 15 over 6. I can't reduce root 15, but could I take a 3 out of everything? Even the 15? So many people do that on a test. The only way we take something out of the square root is if it's a square root, right? That's the only way we can take something out of a square root is if it's a square root. So I can't take anything out of the 15 because there's not a square root. So the 15 is going to stay 15 no matter what I do because I can't take a perfect square out of it. But 3 divided by 3 is 1, and 6 divided by 3 is 2. So it's going to be root 15 over 2. If you wanted to write 1 root 15 over 2, you'd still be correct. Okay? I want you to do B and C and D. All of them have a monomial. All of them have a binomial denominator. So you're going to have to multiply by what? Conjugate. So we multiply by 7 plus root 5. So on the top, I'm going to get 77 plus 11 root 5 over 7 times 7, which is 49, plus 7 root 5 minus 7 root 5. Now, some people skip this step because they're like, well, they just go away. But that step's actually a good step to catch if you actually multiply by the correct conjugate. If you didn't, those two aren't going to go away, and you'll catch yourself. So don't skip it. And then negative root 5 times root 5 is just minus 5. So I'm going to get 77 plus 11 root 5 over 49 minus 5, which is 44. And then I can take a 4 out of here, so 11. 11 out of here, so 4. Oh my gosh. 11 out of here, so 1, and 11 out of here, so 7. So we're left with 7 plus root 5 over 4. Or you could have 7 plus 1 root 5 over 4. It's the same thing. Bless you. C, we're going to multiply by 3 root 5 plus 4. So 2 times 3 root 5 is 6 root 5. 2 times 4 is positive 8. Over 3 root 5 times 3 root 5 is 3 times 3, which is 9. And root 5 times root 5 is 5, and you multiply them. And then 3 root 5 times 4 is positive 12 root 5. Minus 12 root 5. And then negative root 4 times root 4 is minus 16. So I'm left with 6 root 5 plus 8 all over 45 minus 16. What's 45 minus 16? 29? Can I take anything out of 6, 8, and 29? No. The people who do bad in this lesson are the people who believe the answer needs to be like 7 root 3. Like, it ain't going to happen. It's going to be a few terms, and that's fine. Then number 6, we multiply by root 4x minus 1. Six times root 4x is 6 root 4x. And then 6 times negative 1 is minus 6 over root 4x times root 4x is 4x minus 1 root 4x plus 1 root 4x minus 1. These cancel. Now, the 4x on the top, I could actually take the 4 out, it would become a 2. So I'm going to get 12 root x minus 6 over 4x minus 1. You can't take anything out of all of them, but I have seen it where sometimes they take a 6 out of the numerator, but they just leave it out in front, right? Because it can't delete, because you can't take it out of every term in the top and the bottom, so it would have to still stay there. So an alternate answer could be 6 bracket 2 root x minus 1 over 4x minus 1, but still nothing is canceling. Okay? Let's have it on the next page. Everyone have that? We'll deal with this type tomorrow, but that's your homework. I'll cut down on some of it. Tomorrow we're reviewing for your CUME, so we're going to look at sequences and series and quadratics. I'm also reviewing, no, just sequences and series and quadratics. I'm also reviewing at lunch tomorrow, sequences and series, and lunch on Thursday. Yep. So you did a lot of the multiplication yesterday. So number 6, seven A, eight AB is fair. Number 9, do BC. 10, all. 11, all. And then these other ones we'll look at on Monday. So it's mainly this. Because you need to practice all of the questions in order to get good at that. So you aren't like, do I multiply these or do I add them? What do I do here? Because that's what happens unless you practice a lot. I'm going to come around and check your homework from yesterday. If you didn't finish it, don't make me try and decipher if you finished it. Just say I didn't finish it, because that's not cool.